Hey students, before you get this video started, make sure you have your math notebook and something to write with. Today we're talking about section 2.3, 2.3, which is all about dividing mixed numbers. And our learning target, LT, for today is I can compute quotients. Quotients means division. Quotients with mixed numbers and solve problems involving division with mixed numbers. All right, so today's lesson is very similar to our last lesson about dividing fractions. It's just that this time we're going to be dividing mixed numbers. So let's start by talking about what are the steps to do this? What are the steps to dividing mixed numbers? Well, step one is going to be to change any mixed numbers. Maybe both are mixed numbers, maybe only one is. Change your mixed numbers into improper fractions. And as a reminder, the method we can use to do that is MAD. We multiply our whole number by our denominator. We add that to our numerator, and our denominator stays the same. We will do examples of this later, so if you need a little bit more help with using the MAD method, we'll get to do that later in this video. Once you've changed your mixed numbers into improper fractions, then you're going to keep, change, flip, just like we learned in the last video. You're going to keep, change, flip, and you're going to solve your problem, just like we did in our last section. And then finally, once you have your final answer, you are going to turn it back into a mixed number only if needed. If your answer is a proper fraction, if the top is not bigger than the bottom, then you wouldn't have to do this. But if we do end up with an improper fraction, we do want to make sure it's turned back into a mixed number. All right, so now let's do some examples to see how these steps can be put into action. So example number 1, we have 2 2/3 divided by 2/3. So step 1, change mixed numbers into improper fractions. So here I just have one mixed number. I'm going to change it into an improper fraction using the MAD method. I'm going to multiply. 2 times 3 is 6. I'm going to add 6 plus 2 is 8. And then my denominator stays the same. It stays as a 3. The second fraction, it wasn't a mixed number. It was just a proper fraction. So we're going to leave that guy alone. So now our equation says, or our expression, says 8/3 divided by 2/3. Now we're on to step 2. We're ready to keep, change, flip. Keep the first one the same. Keep 8/3 the same. Change to multiplication and flip the second fraction. Use its reciprocal, which would be 3/2, 3/2. All right, now that it's a multiplication problem, we can look for cross canceling. First, let's look at the 8 and the 2. This is like simplifying 8/2. What's the biggest thing that fits into both 8 and 2? Well, that would be 2. 8 divided by 2 is 4, and 2 divided by 2 is 1. Now we're going to look at the other diagonal. We have 3 and 3. It's like simplifying 3/3. So what's the biggest thing that fits into 3? Well, that would be itself, 3. 3 divided by 3 is 1. 3 divided by 3 is 1. All right, we're ready to multiply across now. 4 times 1 is 4, and 1 times 1 is 1. Now we're on to step 3, turn back into a mixed number if needed. Well, look at this. This is an improper fraction. The top is bigger than the bottom, so we are going to have to do that here. How many times does 1 fit into 4? Well, that would be exactly 4 whole times with nothing left over. So this one, our answer is just the whole number 4. All right, let's try that again in example 2. This time we have 3 5/6 divided by 1 2/3. So step 1, turn any mixed numbers into improper fractions. We're going to have to do that twice here. So first, 3 and 5, 6, we're going to multiply. 3 times 6 is 18. We're going to add 18 plus 5 is 23. And then denominator stays the same. It stays as a 6. Now we're going to repeat that. Multiply. 1 times 3 is 3. Add 3 plus 2 is 5. Denominator stays the same. We leave it as 3. Now that we're done with step 1, we can move on to step 2. Keep, change, flip. Keep the first fraction the same. Keep 23 over 6 the same. Change division to multiplication and flip the second fraction. Use its reciprocal, which is 3/5. Now we're ready to look for cross canceling. I'm going to look at this diagonal first, 23 and 5. This is like trying to simplify 23 over 5. The biggest thing that fits into both of those is just the number 1. So that means we will not be able to simplify or cross cancel this direction. Let's look at our other diagonal now, 3 and 6. It's like I'm simplifying 3/6. What's the biggest thing that fits into 3 and 6? That would be 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So now I'm ready to multiply across. 23 times 1 is 1. 2 times 5 is, 23 times 1 is not 1. It's 23. And then 2 times 5 is 10. Now, step 3, turn it back into a mixed number if needed. Yes, we are going to have to do that here because this is an improper fraction. 10 fits into 23 2 whole times, but we would still have 3 pieces or 3/10 left over. So the final answer for this one is 2 3/10. Okay, we're going to do a few more examples. So now we're on example 3. This time we have 3/4 divided by 2 1/2. So just like every one of these problems we've done so far, we're going to start by making any mixed numbers into improper fractions. Now 3/4, that one can get left alone, but we're going to have to change this 2 1/2 right there. We're going to multiply. 2 times 2 is 4. Add 4 plus 1 is 5. Denominator stays the same, stays as a 2. Now we're ready to keep, change, flip. Keep the first fraction the same. Keep 3/4 the same. Change to multiplication, and then flip the second fraction. Use its reciprocal. So now it's going to be 2/5. Now we're ready to look for cross canceling. This diagonal here, I have a 3 and a 5. It's like I'm trying to simplify 3/5. I cannot simplify 3/5. There's nothing that's going to fit into both of those besides 1. So let's move on to our other diagonal. I have 2 and 4. It's like I'm simplifying 2/4. What's the biggest thing that fits into both 2 and 4? That would be 2. 2 divided by 2 is 1. 4 divided by 2 is 2. It's like I had 2/4 and I simplified it to be 1/2. Now we're ready to multiply across. 3 times 1 is 3, and 2 times 5 is 10. Now in this case, our answer is not an improper fraction. This is a proper fraction. The top is smaller than the bottom, so we're not going to have to do a third step. We are all done, and our answer is 3/10. Example 4. We have 2 1/6 divided by 3/4. So step 1, let's change any mixed numbers, in this case just the 1, into improper fractions. So multiply. 2 times 6 is 12. Add 12 plus 1 is 13. Denominator stays the same, it stays as a 6. And this 3/4 can just get left alone. Now we're ready to keep, change, flip. We're going to keep our first fraction the same. 13 over 6 stays the same. Change to multiplication, and then flip our second fraction. Use its reciprocal, so now it'll be 4/3 instead. Now we're ready to look for cross canceling. This diagonal here, 13 and 3, it's like I'm trying to simplify 13 over 3. Well, there's nothing besides 1 that fits into both of those, so those get left alone. Our other diagonal, we have 4 and 6. It's like we're trying to simplify 4/6. What's the biggest thing that fits into both of those? Well, that would be 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So it's like I had 4/6 and I simplified it to be 2/3. Now I'm ready to multiply across. 13 times 2 is 26, and 3 times 3 is 9. Now in this case, we are going to need to do that step 3. We are going to need to change this into a mixed number because right now it's an improper fraction. So how many times does 9 fit into 26? Well, I can fit it 2 whole times. 9 and another 9. We're at 18 pieces, but I have 26 pieces in all, so that means I still have 8 pieces or 8/9 left over. So my final answer here is 2 and 8/9. Now, one final example here, example 5. 1 serving of soup is 1 2/3. 1 2/3 cups. A cook makes 50 cups of soup. Is there enough to serve 35 people? So this question is telling us a cook made 50 cups of soup, and each serving of soup is 1 2/3 cups. So are we going to have enough servings to feed 35 people? Are we going to have 35 servings? So what I need to do is I need to figure out if I divide this 50 cups up into those 1 2/3 cup servings, am I going to end up with 35 servings? So this is a division problem. We're taking our 50 cups of soup, dividing it into our serving sizes of 1 2/3 cups. So step 1 is to make our mixed numbers into improper fractions. In this one, we also have a whole number, so we need to remember that any whole number we can write as that whole number, in this case 50, over 1. All right, now we're changing 1 2/3 into an improper fraction. 1 times 3 is 3. 3 plus 2 is 5. And our denominator stays the same. We leave it as a 3. Now we're ready to keep change flip. So we're going to keep the first one the same, keep 50 over 1 the same. Change to multiplication, and then flip the second fraction. Use its reciprocal, which would be 3/5. Now we're ready to look for cross canceling. If I look at this diagonal here, it's like I have 50 and 5. It's like I'm trying to simplify 50 over 5. What's the biggest thing that fits into both of those? Well, that would be 5. 50 divided by 5 is 10. 5 divided by 5 is 1. Now my other direction, I have a 3 and a 1. It's like I'm trying to simplify 3 over 1. There's nothing bigger than 1 that fits into those, so those get left alone. Now I'm ready to multiply across. 10 times 3 is 30, and 1 times 1 is 1. Now this is an improper fraction, so we need to make it into a mixed number, or in this case, it's actually just going to be a whole number. 1 fits into 30 exactly 30 whole times. So we got an answer of 30. Now what does this mean? Well, this means that if I take my 50 cups of soup and I divide it into the serving sizes, I end up with 30 servings. So is that enough to feed 35 people? No. This amount serves only 30 people.